So good evening, guys. This is gonna be, I think, first of about 4 sessions we're gonna record for this project. So what I have in mind is to basically use this project to sharpen our knowledge of whatever we may have learned as part of SRE, DevOps, or whatever name you want to call it. The objective here is not to start explaining what Docker is to people or what is cloud. It's for people that already know the basics of cloud, SRE, and stuff. And then using this project to kind of sharpen our knowledge of what we think we know, and then giving us the opportunity to use more cutting edge tools that may have evolved, sort of come burst into the scene the last few months or weeks. What I have in mind here is for individuals to take the project on their own, ideally. Um, the reason for that is that there won't be any excuse of Mr. A is not here, or it's not working with me and I'm not able to progress. This is just for you and you alone. Um, and also, the way you're going to go about the work will depend on your skill set and your depth of understanding of the tool sets that may require to do the project. The other thing I wanted to add is that there's no wrong or right answer to it. So your approach will almost certainly will be different to the approach of the other person, etc. But what we are looking for here are people that really want to do the work. So we don't want to be, chasing people. There won't be any chasing actually. So it will be a case of you start the work and then you can report on the main channel and on how you're progressing. We might have sort of midweek session if we think it is required, but certainly we should have a weekend session, which would be to touch base and see where we are on the project. What I have in mind is for us to do sort of minimum sort of hand holding, because I want to give this to people that really know stuff. It will just be a case of me and us. I don't want to be like me. So us working together and pointing to giving pointers of what we think is best approach or a better approach to what a person may have chosen as his approach. The other thing is that I don't want you to limit yourself in terms of what you can do. I want you to go out and try to use all the toolings that you know or that you've read about and you haven't actually used about now, and just bring all of them into this project to just kind of sharpen your tool, to sharpen yourself. So I'm not going to be too worried if you want to go full-fledged Kubernetes, if you want to kind of put even some things on your own, the sort of another layer on top of your Kubernetes. If you don't know Kubernetes, there's Azure sort of the Azure sort of EC2, AWS EC2 or Azure Linux node. That's the level where you operate. That's fine as well. You can use Ansible to provision the boxes and just use sort of sort of VMs to kind of run your stuff. And also, you could go the way of just Docker and just put everything in Docker and then kind of just play out the way you think it makes sense. So what I'm saying here is there's no wrong or right approach. However, the way we're going to kind of score this, because I want us to kind of score it so that you know how good or how much of work you need to do on yourself. I've created a sort of like a table here where you don't have to put your name. You can just use an alias. You don't want people to know you, but you can use that to kind of gauge us. And I will encourage us to use alias. You know who you are. If you want to put your name as well, put your name there. But the way we're going to score this is um, for people that have solid architectural design, everything will be scored over 5, right? If your architectural design is strong enough, which is where the project will start. So we're going to go through what the project is about now shortly. But what the first thing I would expect is to see your design. What does your design look like? So I don't want to start writing code and sort of, running away with it. Let's see what the plan is first. Well, what do you have in mind? This is what I want to do. I'm going to do Azure. I'm going to have 2 machines here. I'm going to have my load balancer here. I'm going to have my HTTPS termination here. I'm going to have my domain registration here and what have you. So we want to see what that structure looks like here. So we want to see the architectural design. So we're going to score that over 5. If you have a CI/CD pipeline that helps with the infrastructure layout, that will be over 5 as well. So if you have a CI/CD pipeline for apps, that will be a 5 as well. If you're structure as code, if you're using Terraform, that will be a 5 as well. And if you're using Ansible sort or whatever for your laying out of your apps, that will be over 5 as well. Containerization will be over 5. If you're using cloud technology, Azure, Google, whatever, it will be over 5. Is your solution scalable? Is it secure? I think I missed one. HA, highly available. I'm going to add it. You have a centralized login to kind of manage logs. That will be scored over 5 as well. And you have login and alerting. So the kind of tools you choose are not to really fuss about. So you can choose any tool that you're comfortable with. Obviously, there are open source tools out there. So Loki, Prometheus, Grafana, those kind of things might be some things that come to mind. But by no means, they are not the only ones out there. So you can choose any solution you like. And also, you don't have to tick all the boxes. Wherever you think you are in your journey, just stick to it. You can push yourself a little bit, and then maybe come to sessions where people will do their own presentation. The way we're going to learn is for people to actually do the work and do a bit of presentation. Also, I want to encourage you to meet. Also, so if you think it will make sense to meet as much as well, maybe with other people and compare notes, you can do that without me compare notes. If you need to bring me, but please don't limit yourself. It's also an opportunity for us to link up as people, yeah, and maybe build relationship, and then see what A knows that you don't know, and then you can sort of, compare notes, etc. So the point here is that we don't have to tick all the boxes, but this is just meant to be a guide to help us as to how we're going to grade this. So please feel free. I'm going to share this. Feel free to put in your details. You can put alias and stuff. And then you can put your alias if you don't want your name to be there. So everything will be graded over 5. And yeah, that's how we're going to play it. So about the project itself. So I kind of just conjure this together. It's now a real project, but something similar to what I worked on in the past. So this is the repo. So if you haven't seen it, so essentially, I kind of make it sort of like a pseudo 3-tier. Sort of, I say pseudo because there's no real database system as it were. So the front end is mainly in HTML and JavaScript, which is basically just HTML document with a few JavaScript in it that kind of serves as a presentation layer. The idea here is that I am a developer. By the way, let's go. So the idea here is that I, as a developer, have been assigned to this project. So it's a PHS algorithm trading platform. And developers have done some good work in writing the code, and they have tested locally, and the code works. I'm going to test it and show us shortly. The plan here is to then take things from where developers have kind of left it and get this simple onboard application to be production ready. Production ready in the sense that when a developer runs this repo, everything will be concentrated or be running on his machine as one single entity, or you would not go to go live with that kind of structure. You want to do a bit of a separation of concerns as well, where each of the elements will have its own independent space. And then you might think of how you can double some services or kind of build redundancy in some services to make sure they are, scalable, highly available, etc. So it's a simple app. You have the front end, the middleware, the middle tier, and the back end. So the middleware, the middle tier is basically a Python application that kind of does the ticker, sort of like a stock information lookup. But the Java application is one that does the caching. So if you look something up, say I'm looking for the value of stock, Tesla stock price. When that value is looked up from the sort of the internet where the stock information is, the data is cached locally, so that if you are looking up the same TCAF, which is stock information, or another time, the system will first and foremost will check if that data exists in the cache. If it does, then it wouldn't have to go outside to fetch the information, but will learn the cache to get the data and display. So that is what the Java stuff is doing. The Java bit is what I reads and write from the cache. Right, the Python application will always query the Java caching layer to see if the data exists. If it doesn't, then it will go to the outside to the internet to pick it up. So you might be thinking, for the Java application, do I need to make it, put it in the maybe in the private subnet because it doesn't need to go to the internet. Or maybe the Python bit because that might have to go to the internet. Do I put it in the public subnet? Like Redis, do I put it in the private subnet? That kind of thing. We want that level of detail so that you can come and explain it to us why you are doing that. The actual design is important. Creation of pipelines is important. We want to encourage you to use cloud technology. We want to encourage you to actually register a domain, maybe www.itoha.com/ stock information. So let's do that. Let's go as far as that. Security in terms of, breaking down of your network. So are you using a /16, a /24? Which one is your VPN? So which one is your public net, private net? It doesn't have to be AWS. And if you don't want to do all that, if you want to do everything on your local machine as well, using Docker or Kubernetes, that is welcome as well. Monitoring is important. If you can implement that, that would be great. And it's just, imagine you are doing this for a top company in maybe in central London or in America and on Wall Street. How are you going to set this up if you are being recruited as the main guy for this? So what are you going to do? So I wanted to push it as far as that. So I want us to do this within 2 weeks. So we are not sort of messing about. So let's make this, let's really push it. I'm going to be checking on the channel. So if you are the person that will have the can-do attitude and you want to keep bombarding me, I'm more than happy to obviously reply to you. But I don't want it to kind of ping me in silent because I won't be able to cope. So let's use the main channel that we have created to kind of manage this. Again, the other thing is that let me just show us what I have in mind. So this is the repo. So a lot of people are asking to join the group. I know them and I'm not deliberately not adding them to the group because I don't want people that are going to be time wasters here. So please, if you're in the group, please let's make it count. Let's do some good work. So this is the repo. So I've tried to put a lot of information there. The Fast API. Fast API is the framework I used for the backend. So this is about the backend. It's just one single. I shouldn't have put this there. So okay, I think I need to put this. I would work if we try. So this is all that is the code. This is how it's calling the Java endpoint. And it will get it if it's a 200, it knows it's there. You can check the code if you want. If you don't need to, you look at it from the standpoint of an implementer. So you don't really need to read the code. But if you're keen on coding and you want me to explain it to you, by all means, ping me. I'm more than happy to run you through this. I did everything. So, and the cache bit is Java. So I use Spring Boot for that. So it's very straightforward as well. So that is the entry point to the code. That is where the endpoints are. And this is where the magic actually happens. So you can see it's very, very straightforward. So, but obviously for this to work, so I deliberately took out, okay, I think I left it there, the Docker Compose file, which would show you how everything we kind of work together. So if I was trying this out, so let me pull it down. Pull it down. Just pull it down. So I will encourage you to please copy the repo and then maybe you fork it into your own local. Okay, I think we've gone on already. Almost that. Okay, I need to. So I'm going to show us how to run the entire project on one node. For this demonstration, I would attempt to set everything up on on Amazon EC2 Linux. So I would choose EC2 Small, which has one CPU and 2 GB of memory. And I think that should be enough to power up all the services. Before I do, let me share my screen. Before I do, I will just refresh this. Should be nothing running. We don't have anything running here. This is my AWS console. But before I go on starting anything at all, this is the repo. So I will install Docker service, as well as Git on the machine. I will use Git to download the code on the machine. I will start Docker as a service, and I would also install Docker Compose binary as well, so that I can run this as Docker Compose on the system. So without much ado, let's get started. Let's take this one out. So I'm going to launch my instance now. I will call it, let's call it a stock demo. Or let's call it that. I'm choosing an Amazon Linux. I'm going to choose a T2 Small. You might be able to get the T2 Micro, but I don't want to risk it because that has a lower configuration. I will then select my key and I will launch the instance. While the instance is being launched, we attempt to refresh. We attempt to update the security configuration to allow access to port 80 on the machine. That's where our web traffic will come in from. So I'm going to add a rule and I'll say HTTP for everything and save that. Okay. And then I will attempt to connect to the system. Okay, so connect. So this is back in, as I would then try to install Docker and Git to start with. It says sudo yarn install Docker as well as Git, and don't ask me any questions. Just install. Okay, and I should get things running fairly quickly. Yeah, so go now. So I'm going to add EC2 user to the Docker group so that we'll be able to run something like Docker PS, which we cannot do right now. Let me start the Docker service first. Sudo service Docker start. Okay, and then if I attempt to run Docker command, it won't work because the Docker itself, EC2 user is not in the Docker group, so you have permission is denied problem. So you want to fix that, just to update the modify the user, add the EC2 user to the Docker group. EC2 user, and then we'll attempt to reconnect, do a full reconnect again, and that should fix it. Let's say it's not running starting now. So let's connect again. Select and connect. And now we should be able to do Docker PS and whatnot. Docker PS. Yeah. So we got Git, we got Docker installed. So the next thing we need to install is the Docker Compose binary, script rather. So I have the script somewhere here. Sorry, I have the link to the script. So I can just run this command, which I will share. And then you can just run it. And that will download the script. And then you need to make it an executable. So sudo change mode, executable. So with that, everything we need to run all to run the stuff on a local machine is there. So we've got Docker Compose, we got Docker itself, and we got Git. So the three things we need. We can then use Git to download the code. This is the location. That's not what we need. It's the location of the code. We can just choose HTTP, copy code, go to instance, and there's a Git clone to copy code. And now we got the code, and we can go in there. So the code here, the same code here. One thing we need to change before we do anything is in front end here, there's a file called index.html. Ideally, if this was a proper real project, we would have created a domain name, and that domain name is where would serve as the link to the location where we have our backend system. So for example, if this was shown stock domain or eton.com domain, so you have eton.com, maybe /stock, that would then take you to a particular endpoint on in your domain. But because we don't have a domain registered now, that's why we are using your domain. So what you should do is when you've downloaded the code to your machine before you run it, go to front end, you see the index file there. What you must do first is to check what your public domain is at the moment. So let's see. Because we are just using EC2 as one node to manage everything. So let's remove running. This is what we got. If we just have one machine where everything runs, we grab the public DNS of that machine. If this was a proper sort of multi-tiered system, you need to grab the domain name of your where you have your reverse proxy set up, which is your nginx. That is the domain name you have to grab, which you would have registered with your with an ISP. We don't have an ISP now, so we use the domain name of the machine. So when you are testing on one single node, just grab the DNS of the machine, and then go on and edit the file. Then let's look for domain, and then that's it. Then we change that to reflect your public DNS, and this as well. So public DNS. And then you can set, obviously, if you're writing a code, if you are using a pipeline, you can use set as in your Jenkins file to look things up and dynamically update it. Yeah, but that file needs to be edited. So we go back one step, and then we can do Docker Compose, up, and run it as a daemon. And that's it really. Yeah, that's it. That will take a while to download all it needs to do, etc. And everything works. We should be able to then go here, pick the domain name, and then stick it in here. But we have to wait for the build for the setup to be ready, which will take a while. So it looks like we have all the services up and running now. So if we check our campus, PS, so everything is running. So we've got the services, the back end, the front end, the Redis, and the stock cache, they are running. So with that, we should be able to hit the web front end from here. Let's see. Okay, so good. Then let's say we test with Apple and say get stock price. Yeah, it's good. So with Tesla, TSLA, get stock price is good. Let's start with Microsoft, MSFT. Stock price is good. We can also tell with SoFi. And stock price is good. And so forth. So if we check here, we can also check the logs. And we'll see all the things that we've entered. So this is SoFi, Microsoft, Tesla, Apple. So we have all the services running on one machine. Obviously, this is just to make you familiarize you with the services. The actual implementation that you are going to do, you have to break this down into different components and have them run separately. Yeah, but this is a good start. If you can get this working up to this point, that would be a good start, and then you can take things from there. Thank you. This is what I would expect is for you to, this is just an example, an illustration. You don't have to do it this way. So I would expect you to have something like your IP, IP, a record mapping, a record mapping. So you have to register your domain. So maybe like dot Shem index or Shem stocks.com, and that a record will map to Nginx. So the Nginx will run on a box, which is the front end. The dial record will map to the Nginx box. Ideally, it should be over HTTPS if you want. And then, so you might have like here. Let's see. Some available services here. So potentially you can have like 2 Nginxes just for redundancy. Okay. And that will be, this is me just saying it. So because this could easily be your Kubernetes environment, that means you won't have to kind of break things into this one. But it could then be a pod, and a pod with 2 instances of Nginx running. And then you then have something like the middle tier, so which is, this is now the Nginx actually, it points to the Python bit, which is what we call the backend.
Well, that would be the cache, isn't it? The cache is in the middle.
No, that's not the cache. So I'll show you. That's why it's important to see this diagram. So this is Nginx backend. This is the backend that speaks to the cache. So this is saying, get me some data. Backend, it would either go to the internet to get the data from using Yahoo API. Yahoo Finance, which is where the stock info is. So that's what it's doing. It goes here. Yeah, but same token, it could use the cache. there is the Java one here. So we're gonna kind of separate with colors. Let's put this one. Just put this green. Then you have the Java one here. So save the Java. So this is now the caching layer. Caching layer. So let's call this a bank as well. So this could go here. There, so you can imagine, and likewise this as well. If you want to use two instances, well, let's make it simple for now. You see what the gist is? It has to be two instances if you can. I think you should make it simple so that you at least understand the concept before you think about getting redundancies. I want the diagram to be simple enough. So the backend can, and the caching layer can return things back as well. So the backend can either go to the caching layer, and so if it's not able to find it, it will go to the internet, get it, and then it will cache it. But what it always does is it will check the caching layer. If it's there, it goes back. If it's not there, then the backend then goes to the caching layer. Then an improvement could be that the caching layer is the one that actually go to your final, but that's not how it works. Currently, the way it works is the backend checks the caching layer. Are you there? No, it's not there. The backend then goes to the internet, which is not great. And then when the data comes, and then it will cache it by itself into the caching layer. So the caching layer, that's the internet. Let's move this away. So the caching layer uses Redis. This is where things are cached. So that's the arrangement. So you have do your record, really load balancer, Nginx, multiple instances if you like. The backend, if you can use multiple instances, that's fine as well. The caching layer will read and write to the Redis backend. And then obviously if things are not in the repo, then we go to the internet to fetch it and then cache it using the cache. This does not speak to Redis directly. It's just a layer on top of Redis, which can read from Redis or write to Redis. This guy would use this chart to write to Redis. So what the Java code does is reading to Redis, reading from Redis and writing to Redis. So I would expect at the bare minimum, you're gonna have Redis. You're gonna have one of these, which is the Java one, the backend one, and the Nginx one.